In this video, I will be explaining you 3 implies 1 part of the theorem 18.1. Okay. Let me continue. So here what we have to do is you are assuming the third condition here and you will prove the first condition. So here is the third condition. I have wrote it. That just copy it down from the question. Okay, so just assume the third condition and you are going to prove the first condition here. That is, your first condition is f is continuous. That is what you are going to prove. First I will tell you, you have to prove f is continuous, right? It means it is enough to prove what? Okay, I will tell you to say f is continuous, by the definition of continuous you have to know something in general. Okay, so you have to say f is continuous, right? So here in our question they are given you a mapping f from x to y. Okay, so to prove f is continuous, what you are going to do is you are going to take an open set from y. If you want to say f is continuous, you have to say inverse image of this open set V is open. If you say that, then obviously then you can say f is continuous. Can you understand how I am saying all these things? I am saying all these things from the definition of continuous. Okay. So here you are taking an open set from this y, that is V, and we are going to say inverse image of this open set is open. That is what you are at the end you are going to say. Okay, f inverse of V is open in x. That is what you are going to say now. So here what we are going to do is, let in between you are doing something. This is what you are going to do, but in between there are some processes. So that is what you have to keep in your mind. Okay, to proceed further. Okay, so to say this, what you are doing is you are let b equal to y minus, we are considering like this, let b equal to y minus v. Okay, I already told you from the y there is an open set V, and we are going to prove, our intention is to prove the inverse image of this open set is open in this x. Inverse image, its inverse image will be open in this x. Okay, that is what we have to prove. If you prove that, then you can say f is continuous. So to prove that, you are doing all these steps. So have a look at this. You are taking b equal to y minus v. As I told you, this v is open in y. There is no any changes in that. Then in the next line, what you have to write is y minus v. Here v is open in y. You have to write all these things. Okay, I wrote it in a with to understand better. To understand it better, I wrote it. Sorry. Okay, I wrote it to understand it better to me. Okay, so that is why I am writing like this. So you have to write the sentences. So I will show you here. Have a look at this. 3 implies 1. This is what the proof. Okay, I showed it. If you want, you can copy it down. Okay, here look at this. You have to take like this, b is equal to y minus v. This b is open in y, then y minus v will be closed in y. Y. Here look at this, v is open in y. When you subtract this v from this y, what will happen? Y minus v will be closed in y. Okay, when you subtract this open set from this y, then this y will be closed in y. Okay, that is what they are writing here. I hope you understand. Let b equal to y minus v. This v is open set in y. You are taking an open set, that is v, and this v is open in y. Then y minus v will be closed in y. Okay, so if y minus v is closed in y, then you can say b is also closed in y, right? Because both are equal. So that is what the next line. Now you are taking inverse on both sides. You get f inverse of b is equal to f inverse of y minus f inverse of b. In the place of f inverse of y, you are putting x. why you are putting x here? So I have no answer right now. Minus f inverse of b. So since f inverse of b, in our assumption we have f in, can you see the assumption? In our assumption we have f inverse of b is closed in x. So that is why in the next line we are writing, since this f inverse of b is closed in x, what you can say, x minus f inverse of b, because both are equal, right? So you can say x minus f inverse of b, v is also closed in x. So from this what you can write? When you subtract f, if x minus f inverse of b is closed in x, then when you subtract this closed set from this x, what will happen? F inverse of b is open in x. Okay. X minus f inverse of b is closed in x. Then f inverse of v will be open in x. That is how you will get that. So you got what you have to say. So from this you can say f is continuous. Okay. Here I got little bit confusion, but I hope you understood what is there in the part. Then you try to understand by your own. Okay.